Today, I am going to deliver a lecture on definition of air pollution, sources, effects and control of air pollution. Introduction. The Earth's atmosphere is 99.9% nitrogen, oxygen and argon. Of the remaining 0.1%, roughly half, 0.04%, is accounted for by the three transition gases carbon dioxide, neon and helium. The remaining minute fraction of the atmosphere is composed of a complex mixture of hundreds of trace gases, the most abundant being methane at 1.7 parts per million. Many gases at the parts per trillion level are entirely man-made but may still have significant effect on the environment. Some trace gases control or affect the Earth's climate and stability. Long-lived gases that are increasing at substantial rates because of human activities are of particular current interest since they lead eventually to stratospheric ozone depletion, global warming and disturbances in atmosphere chemistry that many believe will be harmful to human life. Substantial effects of human activities on the global cycles of trace gases have arisen only during the most recent century. Since 1850, the human population has increased from 1 to 6 billion, bringing with it fast changes in the surface of the earth and disturbing the global balance of the trace gases, changing in atmospheric composition that have occurred are unprecedented during the last several thousand years. The rate of change is much faster now than can occur from natural climatic cycles, although it is hard to prove that there were no times when trace gas concentrations did not rise rapidly and later fall. The changes that are occurring now have their origin in the Industrial Revolution and expansion of technology. These changes are directly related to human events and activities. There is a prevalent belief that the changes man is causing to the atmospheric environment are unnatural and unhealthy. Definition of air pollution. Air pollution is an undesirable change in the physical, chemical, or biological characteristics of air that may harmfully affect the life or create a potential health hazard of any living organism. It can also be defined as a direct or indirect change in any component of the biosphere that is harmful to the living components and in particular undesirable for man, affecting adversely the industrial progress, cultural and natural assets or general environment. It has been observed that wherever such pollutants are introduced in the atmosphere, they enter biogeochemical cycles, characteristic circular paths through which chemical elements tend to circulate the biosphere from environment to organisms and back to the environments through different systems. Again, pollutants accumulate very rapidly into stagnant air masses present over the metropolitan cities, industrial belts of many countries, etc., deteriorating immediately air quality, which ultimately causes air pollution. Sources of air pollution. The pollutants which discharge from different sources may thereafter persist in atmosphere, transform, deposited or degraded. Air pollution results from gases emissions from mainly industry, thermal power stations, automobiles, domestic conversion, etc. Number 1. Industrial chimney waste. Petroleum refineries are the major source of gaseous pollutants. The chief gases are sulfur dioxide and oxides of nitrogen. Cement factories emit plenty of dust, which is potential health hazard. Stone crushers and hot mix plants also create a menace. The suspended particulate matter levels in such areas of stone crushing are more than 5 times the industrial safety limits. There are many food and fertilizers industries which emit gaseous pollutants. There are also chemical manufacturing industries which emit acid vapors in air. Moreover, many cities have also been detected of the presence of photochemical smoke, which is a complex mixture of products formed from the interaction of sunlight with major components of automobile exhaust like nitric oxide, NO, and hydrocarbons. Further emissions and reactions results in the formation of oxidants like ozone and other oxidizing components, including the notorious peroxyacetyl nitrates, acid rain, etc. Some of the major industrial units generating air pollutants are mentioned below. Number 1. Steel mills generate particulates, smoke, carbon monoxide, fluoride. Number 2. Petroleum refineries generate sulfur dioxide, hydrocarbon smoke, particulates, odor. Number 3. Acid plants generate sulfur dioxide, acid mist. Number 4. Paper mills generate sulfur dioxide, particulates, odor. Number 5. Soap and detergent plants generate particulates, odor. Number 6. Fertilizer plants generate particulates, ammonia, sulfur dioxide, oxides of nitrogen, fluoride. Number 7. Cement plants generate cement dust, sulfur dioxide, smoke. Number 8. Thermal power plant generates sulfur dioxide, oxides of nitrogen, particulate. Number 9. Metal smelters generate sulfur dioxide, oxides of nitrogen, particulate, smoke. Number 2. Thermal power stations. The coal consumption of thermal plants is several million tons. The chief pollutants are fly ash, sulfur dioxide, and other gases and hydrocarbons. Number 3. Automobiles. The toxic vehicular exhausts are a source of considerable air pollution, next only to thermal power plants. The ever increasing vehicular traffic density pose continued threat to the ambient air quality. In the major metropolitan cities, vehicular exhaust accounts for 70% of all carbon monoxide, 50% of all hydrocarbons, 30 to 40% of all oxides, and 30% of all SPM. Chief sources of emission in automobiles are: number 1. Exhaust system, number 2. Fuel tank and carburetors, and number 3. Crankcase. The exhaust produces many air pollutants including unburned hydrocarbons, carbon monoxide, oxides of nitrogen, and lead oxides. There are also traces of aldehydes, esters, ethers, peroxides, and ketones, which are chemically active and combine to form smoke in presence of light. The evaporation through carburetors occurs when engine is stopped and heat builds up, and as much as 12 to 40 ml of fuel is lost during its long stop, causing emission of hydrocarbons. Some gas vapor escapes between valves and the piston, which enters the crankcase and then discharges into the atmosphere. This accounts from 20% of the total hydrocarbon emission of an engine. Number 4. Domestic combustion. Major amount of carbon dioxide is released in the atmosphere from burning of fossil fuel, coal, oil, etc. for domestic cooking, heating, etc. From fossil fuels alone, more than 18 into 10 to the power 12 tons of carbon dioxide is being released into atmosphere each year. To some extent, an increase in carbon dioxide level in atmosphere increases the photosynthetic rate and consequently plant growth, acting as fertilizers, especially in hot tropical climates. However, an increase in carbon dioxide concentration in atmosphere may result into disastrous effects also, such as greenhouse effect. Incomplete combustion of domestic fuels gives out carbon monoxide. Besides the four aforesaid sources of air pollution, decaying vegetation, animal matter, especially in aquatic habitats, give off hydrogen sulfide, sulfur springs, volcanic eruptions, coal pits, and sewers also give off these gas. Effects of air pollution. Number A. Effects on vegetation. Air pollution can affect plants to varying degrees. The entry of air pollutants to plants may take place directly by gaseous diffusion or from the contaminated soil, acidic air pollutant in particular. The direct entry of gaseous air pollutants like oxides of sulfur, oxides of nitrogen, carbon dioxide, etc. may take place directly by stomata of the foliages. Solid particulars are, however, absorbed on the surface. In general, pollutants cause injury at lethal concentration on sensitive plants, while tolerant plant species are capable of sinking the pollutants to a considerable extent without any injury. Several species of lichens and angiospermic plants are often used for biomonitoring of these pollutants. Number B. Effects on enamels. The indirect effect of air pollutants tend to occur near smelters treating non-ferrous ores and near factories such as phosphorate fertilizer works, brick kilns, and aluminum smelters where fluorides are emitted and are concentrated in the grasses in surrounding field. Identically, lead compounds from automobile exhausts are deposited near to road. With time, such metals accumulate in animal bodies through food chain and finally posing danger to animal health. The signs of heavy metal poisoning are diarrhea, anemia, and stiffness. Fluorosis is a more widespread problem which affects ruminants, particularly dairy cows. Number C, effect on men. Air pollutants along with breathing air enters the nose and pass it into the lungs where there are a multiplicity of air sacs. The dangers of some small particles such as silica and asbestos lead to specific occupational disease. It is most interesting to note that even at low sulfur dioxide concentrated exposure over a period of 1 year may lead to increased cardiovascular morbidity. There are also possibilities of air pollution-induced carcinogenesis. Extracts of atmospheric particulate showed the existence of polyaromatic hydrocarbons, which are known to be potent carcinogen. Number D, effect on materials. Air pollution have a deleterious effect on materials, stone, paintwork, stained glass, fiber material, monuments, and others. The soiling effect of particulate is obvious in industrial cities where building of light-colored stones and bricks soon take on the characteristic black color. The erosion of the stonework on buildings of great historic and architectural value is very serious indeed. Other results of air pollution are the faster deterioration of clothing, curtains, and wood. The corrosion of metals and the soiling and subsequent cracking of paintwork, silverware tarnishes rapidly due to hydrogen sulfide and sulfur dioxide in industrial cities. Number E, global climate changes. Over the past couple of decades, it was realized that air pollutants cause a considerable change in global climate and associated processes, viz. Greenhouse effects, ozone depletion, acid precipitation, and El Nino effects, etc. Control of air pollution. Number 1. Checking of air pollution from automobiles by monitoring pollutant emission from vehicular exhaust, by controlling evaporation from fuel tank and carburetors, by using filters, and by enforcing some standards through Motor Vehicle Act and other acts for design of engines, etc. Number 2. To save air pollution by industrial plant chimney waste, we must devise measures for removal of the particulate matter and gaseous pollutants from the waste by using cyclone collectors and electrostatic precipitators (ESPs). Standards are to be enforced by the appropriate acts for industries also. Number 3. Through education, the public must be made aware and educated about the menace of air pollution through adequate news media, lectures, and other programs. Number 4. Biomonitoring of air pollution by using indicator plants is also a very well established method. The use of lichens and moss for air pollution level mapping in urban and industrial area of Europe and also in North America are the finest examples of plant biomonitoring of air quality. Conclusion. Air pollution in general and the contribution made to it by automobile is dependent on population distribution. Urban renewal and traffic sanitations are closely related. With growth of urban area, the number of vehicles increase, creating more pollution. To control automobile air pollution, stop and go traffic must be avoided, especially near residential and shopping areas. Highways and streets should have cross-free exits and entrances, over and underpasses to keep traffic continuously moving. Exhaust emissions by automobiles creating pollution may be reduced if positive crankcase, ventilation valve, and catalytic converter are used by public. The preservation of green areas is another important planning measure in reducing air pollution because it can filter out dust, soot, and fly ashes from the atmosphere. Again, smoke and dust particles from atmosphere can be reduced by using electrostatic precipitators.